So let's go to this lesson 2, binary matrix operation, or we are using operation in solving a binary matrix. So the objective of this lesson is to be able to add, subtract, multiply matrices, and same as applying the rules of binary operation. So how do you add two matrices? So uh, the condition here, when two matrices A and B can only be added if they are with the same size, meaning the size of A is equals to the size of B. Let's say A is 2 by 2, then B is also 2 by 2. If A is 4 by 4, B is 4 by 4. A is 2 by 5, so B is 2 by 5. And the resulting matrix is also the same size. And these are the rules in solving or adding to matrix. So each element will be added simultaneously with the other elements. So let's say A11 will be added with B11 with uh, same row, same column. So adding the same row, same column, and the answer will be on the same position. So we have 5 plus 6, so this is 11, then 2 plus 7, 3 plus negative 2, then 1 plus 3, then 2 plus 5, and 7 plus 19. So this is the resulting matrix, which is the same dimension or size with A and B. So this is some example. Okay, so 3 by 4 plus 3 by 4. So the resulting equation or the resulting matrix is also a 3 by 4. So adding simultaneously with each entry, same position or same column and row. Okay. So next is, how do you subtract two matrices? So they are the same condition with addition. So number one is they have the same size. So the difference is adding is addition and subtraction is you have to subtract the elements in the same position. So the only thing is A plus B is not equal to B minus A. Sorry. A minus B is not equals to B minus A. But in addition, A plus B is equals to B plus A. That is law or rules. Okay, so this is an example of subtracting matrix. So A minus B. So we have 5 minus 6, that is negative 1. 2 minus 7. So simultaneous subtraction of each same position in the matrix. So we have 3 minus 2, so 3 minus negative 2, so 1 minus 3, 2 minus 5, and 7 minus 19. So the answer will be the same size as the given matrix. So this is the final answer. Next is, we have sales of these two, we have two location, and we are going to subtract if how many or which is or okay, so how many more tires? So that is the question. How many more tires? So we have to subtract its element in A minus B. So this is the final answer. So the question here is in each quarter. Next is, how do I multiply two matrices? So two matrices A and B can be multiplied if the number of columns of A is equal to the number of columns of B. So let's say this will be, let's say A is equal, the size of matrix A is 3 by 4. B is, we have a 4 by 2. So matrix A and matrix B uh, can be multiplied only if the number of columns in A is equals to the rows in B. So let's see. So the number of columns in A is 4 must be equal to the number of rows in B. So this is, or you can multiply A and B because of that condition. And our final answer, or after multiplying A and B, your final is the number of rows of A by the number of columns of B. So your final answer is 3 by 2. So let's say example. So matrix A is 3 by 4. So we have 1, 2, 1, 2. So we have 4 columns. 3, negative 1, 0, 3. Then we have 4, 6, 1, 5. So this is matrix A with 3 by 4. So 3 rows and 4 columns. So B, matrix B is 4 by 2, meaning that is 4 rows and 2 columns only. So 1, 5, 2, negative 1, 0, 2, and 1, 2. So this is the 4 by 2 matrix of B. And our final answer after multiplying is just 3 by 2. So we have 3, C11, C21, C31, C21, sorry, 1, 2, C22, C32. So this will be our final answer in multiplying these two matrix. So that is a 3 by 2. So let's try to solve that A and B. So we are going to get what are the values of your C11, C21, C31, C12, C22, and C32. So first is, what is the value of your C11? So when we say C11, that is the combination of your first row of your A and first column of your B. So we have to multiply row by column. So this is the first row of A and the first column of B. So we have to multiply, adding and multiply. So the rules is, so this is the rules. Ayan. So that is the summation of A11, AB1, and so on. So that is uh, rows times column. Rows of A and column of B. So let's try this. So that is rows of A and columns of B. So that is the sum of product. Sum of product. So we have 1 times 1, 1 times 1 plus. So we have 2 times 2. 2 times 2 plus we have 1 times 0. So 1 times 0 plus we have 2 times 1. So your C11 is equals to 1 plus 4. We have 5 plus 2, 7. So 1 plus 4 is 5 plus 2, 7. So that is your C11. And we're going to represent C11 as 7. Next, C12. When we say C12, that is your first row and second column. So this is the second column. And we're going to use the first row of A. So we have 1, 2, and 1, 1, 2, 1, 2. And for B, we have 5, negative 1, 2, 2. So multiply and adding, so we have 1 times 5. So that is 1 times 5. Then plus 2 times negative 1 plus 1 times 2. Then plus 2 times 2. So your C12 is equivalent to 5 minus 2 is 3 plus 2 is 5. So plus 4 is 9. Next, so we have C21. C21 is for second rows. So we have 2. Then we have the first column. So we have 3, 1, negative 1, 2, 0, 0, then 3 times 1. So let's try this. So we had 3 times 1 plus negative 1 times 2 plus yeah, they are 0 times 0 plus 3 times 1. So we have 3 times 1, negative 1 negative, times 2, 0 times 0, then 3 times 1. So the answer is 3 minus 2 is 1. So we have 4. We have 6 minus 2, 4. So we have 2, 2. So 2, 2 is the second row and the second column. So we have this and this. 3 times 5 plus negative 1 times negative 1 plus we have 0 times 2 plus 3 times 2. So you have C22. So C21 here. C22 is 15 plus 1 is 16. 16 plus 6 is 22. And the rest, so we have this third row times this. So I will write C1, C31. So C31 will be the third row and first column. So we have 4 times 1 plus 6 times 2 plus 1 times 0 plus 5 times 2. And for the last part, we have 3, 2. So first row and second column. So that is in solving multiplying two matrices. So we have first consider its dimension first before multiplying. So if the number of columns of A is equal to the number of rows. And the final answer will be the number of rows of A and the number of columns of B. So that is uh, multiplying to matrix. Another example, we have 2 by 3 times 3 by 2. So the final answer will be 2 by 2. So A times B, we have first is for C1 to we have first row and second column. So that is negative 56. So the final answer will be 52, negative 56, 76, and negative 88. So after solving this equation. So for your C11, we have the first row and the first column. So that is 5 times 3 plus 2 times 5 plus 3 times 9. So the answer is 52. And the rest we have uh, 2, 2, and 2, 1. Okay, so that is multiplying. So this is example number 6. So yeah, so we have sales of tires of blowout roofs, store, location A. So that is we have to find the sales per quarter. So have to use a multiplication since this is the price per tire of each kind of tire. We have tire, stone, Michigan, and copper. So we have to multiply summation. So we have 33.22 for Tarstone, 40.19 for Michigan, and 25.03 for copper. So this is the sales per quarter, and this row is the type of tire. So we have to multiply each, let's say 33.25. So we have to multiply for 25. So since this is for tire stone. So this 5 will be multiplied by 40.19 since 40.19 is the price of Michigan. The same as for 6, we have to multiply by 25.03 times 6 since 25.03 is the for copper. And this row is for copper. So for first quarter, so the total sale is $1,182.38. Next is for second quarter, so we have this another, so we have 33.25 times 20 plus 40.19 times 10, then 25.03 times 16. So that is for second quarter. The third quarter will be same process, but the third quarter, so same as in fourth quarter, we have 2 times 33.25, then 25 times 40.19, and 27 times 25.0. So that is the sales of per quarter of this company of tires. So we can also consider the scalar multiplication. So we have to multiply by a real number. So m times n matrix times the real number k. So we have to multiply each element by k. So let's say example 2 times. So this is our given matrix. So we have to multiply 2 by the matrix by 2. So the solution is you have to multiply each element by 2. It's the scalar of matrix. Just multiplying. And for this, we have combination. So we have to combine the addition, subtraction, and also for scalar multiplication. So the example is here. So we have given A1, A2, and A3. And since addition, so you have to consider the size of the matrix. So since A1 is A2 by 3, the same as A2 and A3. So satisfy the condition, and we have to add it. Yan. So we have A1 plus 2A2 minus 0.5. So we have to apply the scalar multiplication for each matrix, then apply the addition and subtraction. Okay, so these are the rules of binary. So we have the commutative for addition. So they are the same answer if A plus B is equals to B plus A. So the same for associative law of addition. So with the same size. So you have to consider first the size before adding. So we have A, so B plus C is just the same as when you first add A plus B, then C. Then for associative law of multiplication, this is only applicable if the first matrix is M by N, then the second matrix is N by P, then your third or C matrix is P by R, respectively. Then your final or the resulting matrix will be M by R. Then for distributive law, so that is multiplication, addition, over addition, multiplication and addition rules. So this, ayan, sample, last sample. Okay, so this is if A times B is equals to B times A. So it only exists when A and B have the same size and the same entry. Other than that, they are not equal. Okay, so that's all, and thank you.